Today we are going to take up the atomic models as proposed by different scientists like J.J. Thomson, like Rutherford's atomic model and Bohr's atomic model. So first of all, we are going to take J.J. Thomson's atomic model, which was also described as plum pudding model or watermelon model as it appeared, because J.J. Thomson proposed that an atom appears like positively charged sphere in which negatively charged electrons are dispersed. It appears like the seeds in watermelon and or the dry fruits in plum pudding. So it was named after that, plum pudding model or watermelon model. This model confirmed that the atom is electrically neutral because the negative charge is equal to positive charge and atom is spherical. But the presence of negatively charged particles with positively charged particles merged together can neutralize one another. So it could not explain the stability of an atom. So that is why this model was discarded very soon. First of all, its picture as it matches with the watermelon. You can see it like the positively charged sphere is appeared like the red portion of the watermelon, and negatively charged electrons are like the seeds in watermelon. So it was named after that, J.J. Thomson's watermelon model. He proposed that an atom possesses a spherical shape having radius approximately 10 raised to the power minus 10 meter, in which the positive charge is uniformly distributed. The electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. This model considers that the mass of the atom is assumed to be uniformly distributed, as I have discussed it starting, over the atom. Although this model was able to explain the overall neutrality of the atom, it could not explain any other properties of the atom. So after the failure of J.J. Thomson's model, the second findings were from Rutherford. He performed an experiment with gold foil. He striked alpha particles, which are nothing like positively charged helium nuclei. So these are represented by alpha, called alpha particles, positively charged. He struck these alpha particles on gold foil and observed some very different observation, which led to the cancellation or discardation of the J.J. Thomson's model. He observed that when alpha particles are struck on gold foil, most of the alpha particles passed in straight line or undeflected or undeviated. So some alpha particles are deviated or scattered by some slight angle and some at large angle. If J.J. Thomson's model is right, then alpha particles could not penetrate the atom because the atom as proposed by J.J. Thomson is positively charged sphere. So positively charged sphere could not let the positively charged alpha particle to penetrate through it. So it is clear that the model proposed by J.J. Thomson was not up to the mark. So some more findings are visible on your screen. So the experiment was detected as it is visible on your screen. The alpha particles are being struck on gold foil. As you can see, most of the alpha particles, see this portion, most of the alpha particles are passed undeviated, and some alpha particles are deviated through some angle, small angle, and some are deviated through large angle, and thousands of particles struck, one particle is deviated back. So this is experiment as it is visible on your screen. You can see it. So what are the findings of Rutherford's model? So it is more visible as it is on your screen. The atoms are not positively charged sphere as was proposed by J.J. Thomson. It is vacant. In the center of an atom, the nucleus exists in which positively charged particles, proton, are present. Because positively charged particles, protons, are present in very small space, that is why most of the alpha particle can move undeviated, undeflected. The alpha particle which move close to nucleus, which is positively charged, that feel deviation to some extent. The more close the alpha particle come in contact with the nucleus, more is the deviation. Out of thousands, out of lakhs of alpha particles collided or scattered or passed through the atom of gold foil, the particle that collide with the nucleus cannot penetrate through it. It has to come back. So it proved that the atom is spherical. The atom consists positively charged particle in present in small region called nucleus. These positively charged particles are protons, and electrons, as mentioned by, move in well defined circular path called orbits. So Rutherford explained that the positively charged particles and electrons are present in different places in an atom. So when Rutherford's model was proposed, neutron was not discovered. So the Rutherford proposed that the other particle which will not have the charge but the mass equal to the mass of proton will exist in the nucleus. So most of the, or we can say maximum, the mass is concentrated in the nucleus, in which protons and neutrons are present, and mass of electron is negligible. Electrons are negatively charged, which revolves about the nucleus in circular path. So still on your screen, which where easily you can visualize that the alpha particle can move freely, can move undeviated, because most of the space between nucleus and electron is vacant, and the alpha particle which come in contact with the nucleus goes back in same direction or deviated back, and more close the alpha particle comes in nucleus, more is the angle of deviation that is easily visible on the still. Now next, so now main postulates of Rutherford's atomic model. First is the nucleus is very small. Second, the nucleus is dense. Third, the nucleus is positively charged, in which positively charged protons are present and neutral neutrons are also present, and whole mass is concentrated on the nucleus. Now, the drawbacks of Rutherford's model: when an electron is moving in an orbit, it undergoes acceleration because of changing direction. According to the electromagnetic theory of Maxwell, charged particles, when accelerated, should emit electromagnetic radiation. Due to losing the energy, the electron will slow down and ultimately it will fall in the nucleus, which will diminish, which will spoil the identity of an atom. So in next slide you can visualize it like this. This is a path of electron. An electron is losing energy slightly, and ultimately it will fall in the nucleus as it is visible on your screen. So this is the drawback of Rutherford's atomic model. So to overcome the limitations or the drawbacks of Rutherford's model, Niels Bohr proposed his own model named after his name, Bohr's atomic model. He proposed that, as mentioned by the Rutherford, nucleus is present at the center, in which positively charged protons and neutral neutrons are present, and most of the mass is concentrated in this region, in this small region, and electrons are present in well-defined circular path. This well-defined circular path is called orbit. Bohr modified that in an atom there are many or unlimited imaginary orbits are present, but the electron moves in those orbits in which have discrete or quantized energy. This energy can be represented by En is equal to minus 2 pi square me4 z square upon n square h square, where m is the mass of electron, E is the charge, Z is the atomic number, N is the number of shell whose energy we are interested to find, H is Planck's constant. So on your screen you can easily visualize that the electrons, what we mean by the definite shells or quantized shell in which electron revolve is like that. First shell, which is mentioned as K shell, after that L shell, M shell, so on, or these are numbered as n is equal to 1, means first shell, second shell, third shell, so on. Now, as proposed by Bohr, whenever an electron exists in its shell, it neither absorbs nor emits energy, which confirms that the chances of electron to merge in nucleus are zero. So, whenever electron exists, it will exist in the smallest energy level. So, let us put the value of n is equal to 1. So, the energy of first orbit is minus 21.8 into 10 to the power minus 19. Z is equal to 1 because the Bohr studied hydrogen or hydrogen like element. So if we consider that it is hydrogen whose atomic number is 1, so no need to put the value of 1, means we are going to find the energy of first shell, joules per atom. E1 is equal to minus 21.8 into 10 to the power minus 19 joules per atom, and energy of second shell minus 21.8 into 10 to the power minus 19 divided by square root of 2 is equal to 4 joules per atom. So we can see out of energy of first shell, second shell, the energy of first shell is less. So electron will exist in first energy level, which is called its ground state. Whenever an electron absorbs energy, it moves to higher energy level where it is destabilized. That energy level is called excited state. After absorbing energy, it moves upward like second shell, we can say. So it is excited state where electron is not stable, it is more energy state. So electron has to come back to its original state. So it will release energy in the form of electromagnetic radiation, which will appear as light or a specific color to us, which forms the spectra in hydrogen called hydrogen spectra. So this phenomena you can observe in next slide like that. It is the first energy level, electron absorbs energy, moves upward and releases energy and moves downward, and the radiation appears as a color or light called electromagnetic radiation or hydrogen spectra. Nucleus is present at the center of an atom, and there are quantized energy level energy shells, K shell, L shell, M shell, so on. And energy of first shell, second shell, third shell, the energy of two shells we have already calculated, and we found that the energy of first shell is less as compared to second shell. So what is the difference between the energy of two shells? It is proposed as delta E. It is equal to energy of upper energy level minus energy of lower energy level, means E2 minus E1. So we will find minus 21.8 into 10 to the power minus 19 upon 4 minus 21.8 into 10 to the power minus 19 upon 1 joules per atom. Delta E is equal to 21.8 into 10 to the power minus 19 1 upon 1 minus 1 upon 4 joules per atom. In general, we can write it as 21.8 into 10 to the minus 19 1 upon n1 square minus 1 upon n2 square joules per atom. We have to multiply it by atomic square of atomic number. So n1 is lower energy level and n2 is upper energy level. Like energy, the radius can also be calculated. It is represented as Bohr's model. Rn is equal to R naught n square upon z. So here n is the number of the shell whose radius we are going to find. R naught is equal to 0.52 angstrom. Z is the atomic number So the radius of first shell 0.52 angstrom. First shell means square of 1 divided by 1, as the atomic number of hydrogen is 1. So the radius of hydrogen is 0.52 angstrom, or we can say the radius of first shell, K shell, is 0.52 angstrom. Now the distance from the nucleus of second shell 0.52 angstrom into square of 2 divided by 1 is equal to 0.52 into 4 angstrom. So these value we can calculate, we can apply for different energy levels present in atom as proposed by Bohr. So another thing that we can find is the velocity of electron in different energy levels. So it is represented by V naught Z upon N. So we can find the velocity of electron in first energy level like V1 is equal to, here V naught is equal to 2.1 into 10 raised to the power 8 centimeter per second. So put these values, 2.1 into 10 raised to the power 8 centimeter per second. Z is equal to 1 and number of shell is also equal to 1. So we can find the velocity of electron present in second shell, 2.1 into 10 raised to the power 8 centimeter per second into 1 divided by 2. So you have seen that we can find the velocity of electron in different energy levels as proposed by Bohr. So we can also find the angular momentum mvr is equal to nh upon 2 pi. N is number of shell, h is Planck's constant, m is mass of electron, v is velocity of electron, and r is the radius. So it is the product of mvr is called angular momentum. So Bohr proposed that the angular momentum, like energy, is also quantized, also fixed. So as proposed by Bohr, atom appears as, at the center it is nucleus, where protons and neutrons called nucleons are present, first shell, second shell, third shell, so on. These all are imaginary energy levels which are proposed by Bohr. So Bohr's model on multi-electron atom, if we apply it, it appears as, you can see it on your screen. At the center of an atom, protons and neutrons are present and electrons are moving in well-defined circular paths called orbits. This is the model of atomic model of boron, and second one is of tin. There are some limitations of Bohr's model. First is it was not applied on atoms having multi-electron or more than one electrons. Second, the model as prescribed by Bohr is two-dimensional, but the atom is three-dimensional, so it was not valid to apply two-dimensional model on three-dimensional substance. After that, the de Broglie's and Heisenberg uncertainty principle, which are hardly explained by Bohr. So these were some limitations of Bohr's model. Research is still going on and these all models are discarded now, and we are now studying the atomic model in 3 dimensions. So thank you very much for your patience. Thank you.